Today we are solving LeetCode problem 1411, number of ways to paint an n by 3 grid. We are given a grid with n rows and 3 columns. Each cell must be painted using one of 3 colors, red, yellow, or green. There is only one rule. No 2 adjacent cells, either vertically or horizontally, can have the same color. Our goal is to count how many valid ways we can paint the entire grid. Since the number can be very large, we return the result modulo 10 power 9 plus 7. Key insight. Instead of thinking about the entire grid at once, we solve this problem row by row using dynamic programming. Each row has only 3 cells, so we can analyze all valid color patterns for a single row. Valid row patterns. For a row of 3 cells, there are 2 types of valid patterns. 1-2 color patterns, ABA. First and third cells have the same color. Middle cell has a different color. Example: red, yellow, red. Number of such patterns per row. Choose color A, 3 ways. Choose color B, different from A 2 ways. Total equals 6 patterns. 2-3 color patterns, ABC. All 3 cells have different colors. Example: red, yellow, green. Number of such patterns. 3 times 2 times 1 is equal to 6 patterns. So for the first row, 2 color count equals 6. 3 color count equals 6. Transition between rows. Now comes the key part. How do we move from row I to row I plus 1? From a 2 color pattern, it can transition to 3 2 color patterns, 2 3 color patterns. From a 3 color pattern, it can transition to 2 2 color patterns, 2 3 color patterns. These transitions ensure that vertical adjacency rules are respected. Dynamic programming formula. Let 2 colorways equals number of ways ending with a 2 color row. 3 colorways equals number of ways ending with a 3 color row. For each new row, new 2 colorways equals 2 colorways asterisk 3 plus 3 colorways asterisk 2. New 3 colorways equals 2 colorways asterisk 2 plus 3 colorways asterisk 2. We apply modulo at every step. Final answer. After processing all n rows, answer equals 2 colorways plus 3 colorways. Return the result modulo 10 power 9 plus 7. Why this works? Only 12 valid row states exist. We never generate invalid colorings. We reuse previous results efficiently. This avoids exponential brute force. Example walkthrough. LeetCode 1411. Example 1. Input. N equals 1. Since there is only one row with 3 cells, we only need to worry about horizontal adjacency. Step-by-step counting. Each cell can use one of 3 colors: red, yellow, green. But adjacent cells cannot have the same color. Let's count valid colorings. 2 color patterns, ABA. First and third cells use the same color. Middle cell uses a different color. Number of ways. Choose color A 3 ways. Choose color B, different, 2 ways. 3 times 2 is equal to 6 ways. 3 color patterns, ABC. All 3 cells use different colors. Number of ways. 3 times 2 times 1 is equal to 6 ways. Total ways for n equals 16, 2 color, plus 6, 3 color, equals 12. Output, 12. This matches the example exactly. Example 2. Input. N equals 5000. Here, the grid has 5000 rows, so brute force is impossible. Why dynamic programming is required? Each row depends only on the previous row. We reuse 2 variables. 2 colorways. 3 colorways. We apply transitions row by row. Even with 5000 rows, the algorithm runs in O(n) time. Uses O(1) space. Final result. After processing all 5000 rows using our recurrence relations, output equals 30228214. This value is returned modulo 10 power 9 plus 7, as required. Key takeaway. Small constraints, n equals 1, help us identify patterns. Large constraints, n equals 5000, force us to optimize. Recognizing row patterns converts an exponential problem into a linear one. For the first row, we count manually. There are 6 valid 2-color patterns, 6 valid 3-color patterns. So initially, 2-color patterns equals 6, 3-color patterns equals 6. This gives a total of 12, which matches the example when n equals 1. DP transition. Now, for each new row, we compute how many patterns are possible based on the previous row. From combinatorial analysis, a 2-color row can be followed by 3 new 2-color patterns, 2 new 3-color patterns. A 3-color row can be followed by 2 new 2-color patterns, 2 new 3-color patterns. This gives us the transition formulas. Next 2-color equals 3 times 2-color plus 2 times 3-color. Next 3-color equals 2 times 2-color plus 2 times 3-color. We apply these formulas row by row until we reach n. Now let's walk through the code. We loop from the second row to the nth row. At each step, we compute the new counts using the transition formulas. We apply modulo to avoid overflow. Then update our variables for the next iteration. This uses constant space because we only store 2 values at any time. At the end, the total number of valid ways is simply 2-color patterns plus 3-color patterns. Now let's run the code with a few test cases. For n equals 1, we get 12. For n equals 5000, the solution executes instantly. Everything looks correct. The transitions are accurate, and we're using constant space. Let's submit the solution. And there we go, accepted. Efficient runtime, minimal memory usage, and all test cases passed successfully. That's how you solve LeetCode 1411. Number of ways to paint n times 3 grid using an optimized dynamic programming approach. If this explanation helped you understand the logic clearly, like the video. Subscribe for more LeetCode and interview-focused solutions. Comment below if you want an animated visualization or a similar DP problem next. Thanks for watching, and happy coding!